The position in meters of a hockey ball t seconds after leaving a hockey stick is modelled by r, displacement vector, is equal to 16ti plus 2 plus 3t minus 5t squared j. Find the position of the hockey ball when t is equal to 0, 0.2, 0.4, 0.6, 0.8 and 1. Use these to sketch the path of the ball. Find an expression for the velocity of the ball and use this to find the velocity when t is equal to 0.4. Find the acceleration of the ball and then find the equation of the trajectory of the ball. Okay, so when t is equal to 0, we'll just replace 0 in this. So we're going to get 16 times 0i plus 2 times plus 3 times 0 minus 5 times 0 squared j. And that will give me 0i plus 2j, and we'll plot the point on the graph 0, 2. Similarly, when t is equal to 0.2, we're going to get r is 16 times 0.2i plus 2 plus 3 times 0.2 minus 5 times 0.2 squared j. That gives me 3.2i plus 2.4j. We plot the point 3, 2, 2, 4. When t is equal to 0.4, r is equal to 16 times 0.4i plus 2 plus 3 times 0.4 minus 5 times 0.4 squared j, which is 6.4i plus 2.4j. We plot the point 6.4, 2.4. When t is equal to 0.6, r is equal to 16 times 0.6i plus 2 plus 3 times 0.6 minus 5 times 0.6 squared j. So that gives me 9.6i, 2j. We plot the point 9.62. When t is equal to 0.8, similarly, r will be equal to 16 times 0.8 i plus 2 times 3 times 0.8 minus 5 times 0.8 squared j, and that gives 12.8 i plus 1.2 j. We plot the point 12.8, 1.2. When t is equal to 1, we're going to have that r is 16 times 1i plus 2 times 3 times 1 minus 5 times 1 squared, which gives me 16i plus 0j. We plot the point 16, 0. Right, having done that, we can plot a graph. Okay, so we've got the vertical axis here, the time in So using this GeoGebra app, I've plotted the points. So we've got X here and Y here. And if time moves along, we will get the points that we have just found in the part. We just plot them onto a graph. The GeoGebra app I will put in the notes of the video. Right, if r is equal to 16ti plus 2 plus 3t minus 5t squared j, then if we want the velocity vector, we have to differentiate each component of this. So we're going to get that v is going to be 16i if we differentiate that, and if we differentiate this, we're going to get 3 minus 2 times 5, which is 10t. So 3 minus 10t j. When t is equal to 0.4, because we're asked to find the velocity when t is equal to 0.4, we're just going to get the v is 16i, that's a constant, plus 3 minus 10 times 0.4, which gives 16i j. Going back to the GeoGebra app, so we'll put t equal to 0.4, so that's the displacement vector here. Okay, and the blue one here is the velocity vector. Okay, which you can see is 16i minus j. So to find the acceleration, we just need to differentiate velocity. So we differentiate each component of this. So we're going to get that A is going to be the differential 16 is 0, I minus 10j. When we differentiate this, get nothing from the 3, and we get minus 10j, which gives an answer of minus 10j. Again, going back to the GeoGebra app, if we click here, we can get the, you can see the acceleration is just acting downwards here. Right, the final part, we'll have to find the trajectory of the ball. So from R, we can know that the x component is 16t and the y component is 2 plus 3t minus 5t squared. From 1, we can say that t is x over 16, and then we'll substitute it into here. So everywhere there's a t in here, we'll now replace it with 16x over 16. So we're going to have that y is equal to 2 plus 3 times x over 16 minus 5 times x over 16 squared. So make sure you substitute into brackets. So that's going to give that y is 2 plus 3 over 16x, and then if we square 16, we get 256x squared. So this is the path of the ball, and relating that back to the graph, if we just get rid of these points here and we click on the last one here, this is the trajectory of the ball with this equation. Okay, so this has been a video to model the path of a hockey ball. I hope you've understood, and I thank you very much for watching, and I'll repeat, the GeoGebra app I will put in the notes of the video. Thank you very much.